When you encounter a novel environment, your cognitive load spikes. Your brain has to analyze every variable and process overwhelming amounts of incoming data just to determine its next move. This process is expensive. The human brain consumes a massive share of the body's total energy, and it is biologically hardwired to seek ways to minimize that expenditure. This neurological cost-cutting is known as automaticity. Through repetition, your brain learns to isolate essential signals from the surrounding noise, forging a direct, efficient pathway to a solution. Conscious decision-making requires high friction and high energy. Automatic execution operates with low friction and low energy. From a biological perspective, a habit is simply an energy-saving algorithm. Its purpose is to solve recurring problems with the least possible effort. For decades, behavioral psychology relied on operant conditioning, a model that reduced behavior to a simple sequence of stimulus, response, and reward. While this explains reactive reflexes, it struggles to predict human behavior in complex modern environments where internal states play a role. In Atomic Habits, James Clear expands this framework into a four-step cybernetic feedback loop. By factoring in our internal cognitive states, our moods and beliefs, habits transition from simple reflexes into predictive algorithms. We will now deconstruct this four-step engine node by node. Understanding the mechanics of this loop provides the blueprint for designing environments that drive specific behaviors. Any habit divides into two distinct halves. First is the problem phase. Here, the brain recognizes an opportunity or threat. It begins with the cue, environmental data predicting a reward. This prediction triggers the craving. You crave the change in internal state the habit delivers. Crucially, external cues carry no inherent value until they are interpreted by the observer. Consider these vintage slot machines. To someone who rarely gambles, the bells and lights are just background noise. But to a gambler, these exact same triggers spark an intense wave of desire. The problem phase depends entirely on the user's internal state, transforming raw data into actionable desire. Once desire generates, we enter the solution phase, the external action taken to resolve internal tension. Here lies the response, which occurs if motivation outweighs difficulty. Executing it delivers the reward. Rewards satisfy the craving and teach the brain which actions are worth repeating. The solution phase is where internal cognitive predictions are converted into measurable physical behaviors. These stages form a continuous feedback loop. As Edward Thorndike's 1898 experiment showed, actions followed by satisfying consequences etch into memory. With each cycle, neural connections tighten, a process called long-term potentiation. But this loop is fragile. Eliminate the cue, and it never initiates. Reduce craving, and there's no drive. Make the response difficult, and execution fails. If rewards fail, the behavior extinguishes. Ultimately, this is a sequenced biological loop. If any stage fails to fire, the behavior cannot achieve automaticity. True habits are processes that reach the deepest layer, your identity. Relying on willpower to force an outcome is a struggle against your brain's natural energy-saving heuristics. By manipulating the four steps of the feedback loop, professionals can create an environment where the right behavior is the path of least resistance. You do not rise to the level of your goals. Individuals and organizations alike ultimately fall to the level of their engineered systems.